Hello. In this video, we're going to go through and work through this question, which is essentially applying the concept of transformations to a quadratic. I'm going to do this video in a little bit more of a... Hello. In this video, we're going to work through the graphing of this relationship, y equals 1/2 x plus 1 squared minus 2, using our ideas of transformations. So the first thing we want to think about is what are the progressions that are happening. And I like to say, what are the transformations that I'm going to apply and in what order? And the really important thing here to remember is the following. Shifts last. Sometimes students will learn these ideas, and their teacher will say reflection, stretches, shifts. Some teachers will say stretches, reflection, shifts. It actually doesn't matter if you do a reflection or a stretch in what order, as long as you do your shifts last. Very important. So what I'm going to do when I write down the progression of the transformations I have to apply is I'm going to talk about the stretches and reflections, and then I'm going to do the shifts. So we see here this has no reflection, it simply has a vertical stretch. So the first transformation is a vertical stretch by 1/2. So that's what we think of it in words. Now we want to think about what do we do mathematically. So we take all the y values and we multiply them by 1/2. With transformations, it's important to think, what are we doing in words and what are we doing in mathematics? The second transformation, and I typically group these two together, are our shifts. So I see I'm going to shift left 1 and down 2. So remember, x plus 1, this plus 1 is what tells us about our horizontal shift. So plus means to the left. Remember, it lies. And this minus 2 tells us about our vertical shift, so minus 2 is 2 down. It's always good to go back and justify why these shifts are applied in this manner, and you can do that using a table of values and graphing it, putting a couple examples in there. So we're going to say x minus 1, and we're going to say y minus 2. That's what we have to do mathematically. So we'll start off by graphing the parent graph. So this should almost be second nature now for a lot of us. So there is one side of the quadratic. I'm going to use a symmetrical argument here and go over 1, over 2, over 2, over 3, over 3. I like to highlight this technique because symmetry is a great thing about a quadratic. It allows you to recognize a lot of really interesting features and do a lot of neat things. So don't forget about that symmetrical behavior that's going on. It also allows us to minimize our work, and I'll show what I mean by that in this video. So remember, what we're trying to do is we're starting from this parent graph and we're going to apply these transformations to end up with our child graph, our end result. We're doing this painstakingly with points. Ultimately, what we're interested in is not that you can walk away from this and be able to do these really fine-grained examples and plotting a bunch of points. We want you to walk away from this with an appreciation of behaviors and patterns within graphs, to be able to look and get general ideas of the trends. And this is how we kind of develop that. So what I'm going to do is I'm going to do this in a little bit of a longer format. So sometimes students can take these transformations and they can put a point on their pen on the graph. So if I take 0, 0, and I'm going to apply the transformation. So I can multiply the y by 1/2, it doesn't move. I'm going to move 1 to the left and 2 down, and that's where my new point is going to be. Okay? And that can be tricky when you're first learning this. So what you can do is you can actually go and write down your points on somewhere on some rough paper, and you'll notice I'm taking the points only to one side, one branch, because I'll find the other ones using the symmetrical argument. And then what I do is, the first step is I'm going to apply transformation 1. So let's do transformation 1 in black. So what I'm going to do is I'm going to multiply the y value by 1/2, so this stays at 0, 0. This becomes 1 and 1/2. This becomes 2, 2. This becomes 3, 4.5. And so now I'll plot this first transformation. So 0, 0, 1 and 1/2, 2, 4, 3, 4.5. And this is where we have to make sure we kind of think beyond our points that we're transforming, because notice with the parent graph we have 416, which is somewhere off this chart. So, but when we apply the transformation, 416 is going to become 48. So now that's actually on the grid. So I have to be sure that I account for points that might come onto the graph. And then it kind of comes up like this. Now, like I said, you don't actually have to do this process for the other branch, because we can really quickly use a symmetrical argument. Cross, across 2, across 2, across 3, across 3, 4, across 4. And then we kind of come up like that. So there's our next step. So now what I'm going to do is I'm going to do the second step, and let's do that in gray. So now I'm going to take this and I'm going to do step 2. So what I'm doing is I'm taking a moment here on the right hand side of this page to actually map out the process. So I'm going to subtract 1 from x, and I'm going to subtract 2 from y. So this is going to become -1 minus 2. This is going to become 0, comma, minus 1 and 1/2. So minus 3 over 2, let's say. This is going to become 1, comma, 0. This is going to become 2, comma, 2.5. And this is going to become 3, 6. So I'm going to start with the new vertex, which is -1, -2. And I can confirm that by looking at the original form, because we know we should be able to read the vertex right off the original vertex form equation. Once I've put my vertex, I'm actually going to dot in my axis of symmetry here. Axis of symmetry. I like to make sound effects while I graph sometimes. So 0, 3 over 2. And then I have 1, 0, 2 and 2.5. And then I'm going to have 3 and 6. 1, 2, 3, and 6. There we go. And again, if I go and connect these, I might get a little concerned about, well, what's going to happen to the rest of this grid. So I could test x equals 5 if I want. So I'm going to say y is equal to 1/2 times 5 plus 1 squared minus 2. So that's going to be 1/2 times 36 minus 2. 36 divided by 2 is going to be 18. So that's going to come right. That's going to be up here quite a bit. So we're just going to go straight up like that. Okay? Oh, we should be testing x equals 4 actually. Pardon me, because we want to check this value here. So we're going to test x equals 4. 25 divided by 2 is 12.5. We get 10.5. So we want to make sure that we're at 4, we're about 10.5. And now, as opposed to going through all these processes with the other one, I'm just going to use that nice, that nice symmetrical argument. 1, 2, so cross 1, 2, 3, 1, 2, 3, 4 across, 4 across, 5 across, 5 across, pardon me, and there's my resulting sketch. Okay. So a couple of things that we want to highlight is it's really nice to note that we could make this large table and we could map each point manually. Ultimately, what we want to get to is to be able to put our pen on the graph and kind of walk through each point. And again, if you transpose each point that's on the parent graph, you might not get all the points that fit on the grid for the resulting child graph. So you might need to test some points at the end. And of course, we want to fill in the core information. The vertex is going to be, we can see right from this, it's going to be -1, -2. Oops, pardon me, I wrote that backwards. -1, -2. And again, yes, we can read that on the grid, but you should be able to read it right from the equation. It's going to have a minimum. You know it's a minimum because A is positive, and the minimum is going to be located at the vertex. The direction of opening is up because A is positive. The axis of symmetry is going to be x equals -1. Remember that axis of symmetry is always an equation, and it's an equation of the x value of the vertex. And then to find the y-intercept, we're going to set x equal to 0, so y is equal to 1/2 times 1 squared minus 2. So we're going to get 1/2 minus 2, which is equal to -1 and 1/2. Okay, so I went through that math there, but you notice we actually have right there, there's the y-intercept right there, 0, -3/2. Okay, so initially take a little more time and actually map these out slowly. Don't rush through a question. Speed will come on its own with more practice and identifying patterns and neat little tricks. And also, you don't necessarily need this grid to graph this. If you did a quick sketch, make sure you include points at the vertex, the x and y intercepts. And again, we're more interested in the general shape and the behavior of the graph. The reason we go through this transformation process is so we can look at a variety of types of relationships a little later and get an idea or a feel of how they behave. I hope this helped.